Welcome to the class, student. We'll continue the chapter hydrocarbons. This is the last part of hydrocarbon, aromatic hydrocarbon. In this we'll study about benzene and its compound. And benzene is having molecular formula C6H6 and the structure formula is written here. And if I write the whole thing of this, so we have a 6 carbon. And every carbon is attached with one hydrogen atom. Every carbon attached with one, and every alternate bond is a double bond. So this is the structure of benzene, and you have to do calculus structure. This calculus structure gives the information that the position of the double bond is not fixed. If you mark this as carbon 1, this is 2, 3, 4, 5 and 6, and here also 1, 2, 3, 4, 5 and 6. So the double bond here in this structure, you can see it is between 1 and 2, but here it is between 2 and 3, and similarly 3, 4, so here 4 and 5, here it is 5 and 6, so here it is 1 and 6. So this is your oscillating position is not fixed. That's what is written here. The position of double and single bonds is not fixed but oscillate between adjacent position. So these two structures which we have got, they have got position of the double and single bond different, and so that will be differentiating the two structure. So in this way there remains no difference between the structure of A and B. Basically there is no difference, only that the position is a change. So every alternate bond is a double bond. So you have to do now resonance and stability of the benzene ring. So resonance, that is what is this resonance that we will see, and this is resonance is a phenomena in which the molecular formula will be the same of a compound, but will have different structural formula. This we have done earlier also. While I was taking mechanism, I have explained that to you. And then these structures which we have, different structures of a compound, none structure, neither this structure is a true structure nor that structure is a true structure, because here it tells that double bond is between these two carbon, and this structure says that between these two carbon it is a single bond. So none of the structural formula will be the true structural formula, and the formula of the compound will be mixture of all. So that is called resonance hybrid. So resonance provides stability to a molecule, and that's what we are going to see. So benzene considered to be resonance hybrid of these two structures. So resonance hybrid we write like this. This is hexagonal. Instead of writing every alternate bond double bond, we put a circle in the middle that is showing that double bond is oscillating. The structure of orbital structure, how this carbon atom is bonded with hydrogen and other carbon atom, and the hybridized state, that hybridization you have not studied so far, and Dr. Dwivedi will be teaching you hybridization, and then there he will be explaining to you the structure of benzene on the basis of hybridization, and then you will be able to see that how double bond and single bond oscillate, their positions are not fixed. I told resonance is a phenomena that will be showing the single structure such a way that the position of the double bond or the single bond that will be different. And now so you can see here, when a single structure cannot explain all the properties of a molecule, as these two structures we have taken, so of the benzene as calculus resonance structure, but benzene can be written in a different more than 60 structures form, and none of those structure out of 66 and actually more than 60 or approx 66. So none of those structure will be giving the true structure of the compound, and not a single structure out of those 66 structure will be able to explain all the properties of the compound. So here a few of them I have written down for you. So these two are calculus structure as we have seen earlier. And then if this bond is not there, so you know a pair of electron will be free. So one of the, this is actually from here, this bond got broken. So you have got a pair of electron free. So one of the carbon atom is having the pair of electron, and this carbon has a lossless electron to this carbon. So on this there is a positive charge and here is a negative charge with a lone pair. Same thing can happen that this bond remains here, this bond breaks. So here positive, here negative, this will be another structure. Similarly this will break. So here positive and here negative. So like this will be giving 3, this will be giving 3. So those all you can also use, draw. Those are the one thing. Then the other structure is that as you see that every carbon atom is having one single bond and one double bond. So if you see like this, here this carbon has a single bond and a double bond. This carbon has got one single bond and these are the two bonds. Okay, so like this can be written in different form. This way, that way, this way. Okay, and so this can also be written in many ways. So those will also be the resonance structure. Another kind of writing structure is if this bond breaks and their contributed electron, one pair will be free. So one electron will be taken back by this carbon and one electron by this carbon. So each will have one their electrons, and so this way it can be here or here or here. So like this many more structure can be written. So like this that benzene has got many structures, but none of the structure will be giving the idea information about the property, all properties of a compound. So this is telling that double bond and single bond property. This is showing polar nature, positive and negative charge. This is a neutral molecule, and here again you can see the two double bond, and this way the cross bond, and here you can say that polarity is there but not a complete positive and negative charge, no ionic characteristic. So different properties are there shown by different structures, and so here you can see then two or more structures are given to that. So here you have a number of structure. The molecule is considered to be the resonance hybrid of all these contributing structures. So as I told you earlier that these two structures A and B can be written like this. So we can write as a circle. So this whole thing can be written like this, and this is called resonance hybrid, which I have written there. So actually resonance hybrid is there and none of this structure is a true structure. So the real structure of the molecule cannot be represented by any one of the canonical structures. These resonance structures are called canonical structures also. Either you say them canonical structure or you call them resonance structure. It is same. So contributing structures, that is your resonance structure or canonical structures. Then since here you see in calculus structure, we have carbon-carbon double bond and carbon-carbon single bond. So carbon-carbon single bond which we see in alkane, that is having bond length 154 picometer, and the double bond which we have in alkene, that has the bond length 134 picometer. But in benzene, a double bond and a single bond, they neither have double bond, neither have 134 picometer the length, and single bond nor single bond is having 154. Instead, whether it is a double bond or a single bond, every carbon-carbon bond, that is whether carbon-carbon single bond or carbon-carbon double bond in benzene, each will have 139 picometer the bond length, which is this value. If you see, it is intermediate of these two. So neither it is a pure single bond length nor it is your pure double bond length. So this is about the resonance, and next we will see the aromaticity. So now aromaticity, this is the property shown by benzene and its compounds. And how to decide whether a compound is having aromaticity or not? There are several conditions, but only two conditions you have to do. One is that the molecule should be cyclic and containing one or more double bonds. And the pi electron should be delocalized. Delocalized means you have understood already that its position is not fixed. Like in benzene, calculate the structure. You have seen double bond can be shown this way, either here or there. So even here double bond, the next moment here will be the single bond. So this is delocalization. Positions are not localized, not fixed. So these are canonical structures separated by double-headed arrow. And so that is the meaning pi electron should be delocalized. Pi electron means double bond. Then through Huckel's rule you can find out, one is that it is cyclic and one or more double bond. अगर cyclic है, double bond है तो aromatic हो सकता है. And beside that we have Huckel's rule also. So Huckel's rule, this is your Huckel's rule, 4 plus n, 4n plus 2 pi electrons. So you will calculate here where n is small n. This is small n, that is can be 0, 1, 2, 3 pi electron. So if you have to find out in the benzene ring, that is what it is. So this n is your number of your pi electrons. So here you can count 1, 2, 3. We have 3 pi electron. So you will substitute in the formula. Pi, this will be is equal to 4 into n, 1, 2, 3 plus 2, and we will have your water, 4 3s are 12 and 2 14 electrons. So altogether we have 14 electrons. So that is here, and it is having your 3 double bonds. So you should know the total number of electrons also, how to calculate, and you should know the formula, Huckel's rule. So because of this we have got, so if the number of electrons are 14, then possibility is there that we will have 3 double bonds. So although they have, benzene is having 3 double bond, it is unsaturated, but it doesn't undergo addition reaction very easily like alkenes and alkynes. It doesn't undergo addition reaction easily. Normally it undergoes substitution reaction. And also oxidation reaction, it doesn't undergo easily like your alkene and alkynes. Instead it does easily undergoes substitution reaction, and that substitution reaction we will be studying later on in its property. And because of the resonance it is more stable. Although alkenes and alkynes, compounds which have double and triple bond, they are not so stable, but benzene is stable because of this resonance. So resonance makes a molecule stable. You know benzene. These both are laboratory method. This compound is sodium benzoate. This is just like your alkane methane as we have prepared. If you remember, we had CH3CONA sodium acetate, and this compound is C6H5CONA. This is sodium benzoate. Is that way or this way you write. So if you see both are having both are analog, that is same like and when this is heated with soda lime, then we get alkane. So when this is heated with soda lime, distilled with soda lime, we obtain benzene. So here we obtain benzene. Na2CO3. Na2CO3 is out. This H will be attached there and we get benzene. Second method is from phenol. This is phenol, which you can write like this also. And this is heated with zinc dust, zinc powder. If we heat, then this oxygen will combine with this to give zinc oxide, and benzene is obtained. So this is again benzene. Only these two methods we have to do. In your book a number of methods are there. but they all have been removed from this reduced syllabus. So now physical properties. First physical property, it is colorless, mobile liquid having characteristic odor. You have to learn it, that's all. It boils at so much of the temperature, this much Kelvin, and on cooling it solidifies to a white crystalline solid that melts at 278, means 5 degrees Celsius. And freezing point is so much, 278.5, and density, that is, it is lighter than water. So next we will do, that is chemical. It undergoes addition reaction, but under drastic condition. Drastic condition means high temperature, high pressure, catalyst, and not easily. So then these are the 3 examples of addition reactions we have to do. With hydrogen on double bond, one hydrogen will be added, one hydrogen here, one here. So all double bond will be turned into single. So this benzene is converted into cyclohexane. And with chlorine in the presence of sunlight, it undergoes addition reaction, and on every carbon atom chlorine will be attached and hydrogen will be liberated. So 6 HCl will be out, and not HCl will be out. This is chlorine is added, and we will have benzene hexachloride. C6 H6Cl6 will be the formula. And this is called benzene hexachloride. BHC is for benzene hexachloride, and also called 666, also called indane or gamaxine. Must have heard about it. Gamaxine, which is an insecticide. Which is used to kill the insects. Then ozonolysis is like your alkene that we have done already. If you remember that, I do this reaction for you. One ozone, that if you remember, the reaction went like this. CH2 double bond CH2 ozone, and this bond got broken. Then this ozone, which is splitting into this and this. So one oxygen was commonly added, and this was the compound ozonide obtained, which underwent bond breaking at 3 places. So this thing we are going to do at 3 carbons. You can mark 1, 2, 3, 4, 5 and 6. So we have got carbons 1, 2, 3, 4, 5 and 6. So this will be broken. So this is here both bond will be broken, and so to this carbon and to this carbon one oxygen will be commonly attached, and one oxygen here, one oxygen here, like this. Okay, and then we have this bond. When this bond got broken, then we have got carbon and carbon commonly linked oxygen, and these are bonded. Then this bond is broken. Then we have carbon and carbon commonly linked oxygen, and interlinked. So this way you have to do at all 3 your double bonds. Then bond has to break from 3 places, either side of single oxygen and from the middle of the 2 oxygens. So middle of the 2 oxygens like this, and either side of single oxygen like this. It will break. So what do we have? We have the, see, it's broken, so we have this one, this is here. So we have this broken here, and this is like this. And like this, one piece is like this. Then another piece we can go, this oxygen is out. Here these 2 carbons, and then this oxygen like this. And then this is carbon 5, these both oxygen, and this is a linked, and here we have got this. So what is the product form? So this way if you do, it is quite complicated for you. So simply you can remember that when you do the structure, very simple, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6. Don't draw any bond. Commonly you link oxygen. Not to every carbon but to alternate carbon. To every alternate carbon you link 2 oxygen between the 2 carbons. And with every carbon atom you attach oxygen. With every carbon attach oxygen. And then remaining carbons which are not attached, you link them. C4, C5. So this way the ring will be formed. And here oxygen, oxygen, linked together, oxygen, 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 oxygen. And so when this will be broken, this is getting broken from here, getting broken from here, getting broken from here, getting broken from here, this. This is getting broken. So what we will have, carbon 1 attached to carbon 6. Carbon 1 has 1 oxygen. Carbon 6 has 1 oxygen. 1 hydrogen is with carbon 1, 1 hydrogen is with carbon 6. So the fourth valency will be satisfied by a double bond. So same thing will be with C2 and C3 and C4 and C5. So you will have 3 molecules of this. This compound is glyoxal. You have joined in acetylene. So this need only writing practice. If you take practice, you have understood ozonolysis in alkene and alkyne, then you will have no problem in doing this. But if you have skipped there, then you will have to skip here also, and you will have to want to learn, then sit, write, draw and practice. So we'll do first that. Next thing is a substitution reaction. The reaction, they show Sc2 reaction. You know the full form of this. Bimolecular, 2 is for bimolecular electrophilic substitution reaction. So these are the examples which we have to do. So here I teach you first the mechanism. So benzene ring, always this reaction takes place in the presence of Lewis acid, anhydrous ferrichloride, and sulfuric acid concentrated is also the Lewis acid. And beside this, you can use ZnCl2 anhydrous and AlCl3 anhydrous. Any one of these 3 could be used as Lewis acid. In particular these cases, but in these 2 cases, sulfuric acid will be playing the role of Lewis acid also. So first I teach you the mechanism. So what happens that now just you have studied the mechanism part. This is substrate, this is addendum, and so benzene is substrate and chlorine is addendum. Benzene is substrate, nitric acid is addendum. Benzene substrate, sulfuric acid is addendum. Benzene substrate, alkyl halide is addendum. Benzene substrate, acid chloride, which is a acid derivative, that also we have done in mechanism part. Many more acid derivatives are there. Acid amide, acid anhydride. This is acid chloride addendum. So I'll be using the term substrate, that is your benzene, and addendum is your Lewis, your compound which is attacking. So first of all, the Lewis acid, you can take any Lewis acid. I have taken FeCl3, so I take over here. FeCl3 is combining with the addendum. This addendum is if there, so I take addendum like A and B, maybe same both or different both. So in that case, addendum will be splitting into 2 parts. One will be positive, other will be negative. So if it is chlorine, it will be splitting into chlorine plus and chlorine minus. This will be splitting into minus and plus this side. This will be splitting like this. This will be splitting like this, and this will be splitting like this. This is carbonium ion, this is acylium ion, acyl group, already done in mechanism chapter. So plus part is there, and when this Lewis acid comes in the contact of addendum Lewis acid, the central atom is having deficiency of an electron. You have done, must have done in the physical chemistry, the Edison must have taught, or if he has not taught, he will be teaching you later. That is, there are some compounds in which the central atom is not having its octet complete, it is having less than 6 electrons. So, Lewis acids are those in which central atom means aluminium, zinc and iron. They have a deficiency of electrons, although they established a bond, but they don't have their octet completed, which you have studied. It's an essential rule for a bond to be formed. So here this is having positive charge, it will be attracting the negative end, and we will have FeCl3, and this B is attached and A plus will be released. So this is first step. Now this A plus, this is called electrophile. So this A plus is nothing but it is your electrophile, electron loving. So this can be represented as E plus. So this is electrophile, this is electrophile, this is electrophile, this is electrophile, and this part is electrophile. So electrophile will be going to the benzene ring. So positive one has come over there, positive one has come over here, positive here, positive there, and so that's why the reaction is electrophilic. And in the next step, what will happen, that the benzene ring which we have, that will be one of the hydrogen atom I show, which has to be substituted. This will come in the contact of electrophile. When it comes in the contact of electrophile, this is getting electromerized, and electron is transferred this side. So here will be negative charge and here will be the positive charge, and double bond will be turning into the single bond. So here this is happening, that is hydrogen, and here is your positive charge, here this and lone pair and a negative charge. Because of this negative charge, lone pair electrophile attacks here and is getting attached. So this step is not shown directly, E is attached. So electrophile is attached means here this your A is attached, E is representing in this case A plus, and in this case electrophile, this chlorine, if it is chlorination, then Cl will be there. If it is this reaction, nitration, reaction with nitric acid is nitration, you know already. So nitronium ion, this also you know, electrophiles you have done earlier. Nitronium ion as electrophile, this is electrophile, this is E plus, this is E plus, electrophile, this is electrophile, E plus, this is also electrophile, this is also electrophile. This will be going and attaching there, and we will have this compound form. But this compound is resonance stabilized. So 3 resonance structure it will be forming. The another resonance structure I draw here. H is there, E is there, and this plus charge, and so this pi electron, which is excess of electron, will be transferred over here. And so what we will have, a double bond here, the positive charge here and a double bond here. This bond will break, pair of electron will be here, positive charge will be here, and so this positive charge will be balanced by this pair of electron as a double bond. One more structure can be there, that is H and E will remain as it is, and plus charge will be here, and this is, so these 3 are resonating structures of benzene when electrophile has attacked on it. So resonance structure 1, resonance structure 2, and resonance structure 3, and just today you have seen none of the resonance structure, canonical structures are the true structures, and the true structure is the intermediate. So hybrid of these all three is there, which we can write like this: positive charge, rotating E and H. So this is resonance hybrid. Now this is your second step. This is this is your first step and this is your second step. In the third step, your resonance hybrid, which you have H and E, this will be combining with this part, with B is attached, so here developed a negative charge. So this will be combining with FeCl3 and B and a negative charge. So in this case, your negative chlorine went to FeCl3. In this case, negative OH will be attached to this, which you can write along with this as OH ion in the mechanism part. In place of this part, you can write this part, and then in this case, this OH will be linking to this OH, and in this case, X will be linking to Lewis acid, any Lewis acid which you have taken, ZnCl2 X. So minus charge, and this will be chlorine will be attaching to the anhydrous. So everywhere it is the same, only you remember where which is going. If you know this in general, the mechanism, you can do any kind of reaction out of these five. So in this case, what will happen? That this is here, this will be trapping one hydrogen out from here, and FeCl3 will be re-established, and B and H will combine, and a byproduct will be formed. And hydrogen will be leaving its electron here, and so therefore this positive charge will be balanced. So this FeCl3, which is reformed, that will be the byproduct, BH, that is the byproduct, and the main product will be your benzene ring, and your electrophile is attached. So this is what the final thing. This E, as I told, this one of the chlorine is E. So this chlorine is E, this nitro group is E, this sulfonic group is E, this alkyl group is E, this acyl group is E. So these are the five reactions, and you can use this in general. I have taught to you, and you can apply accordingly, and if you must take practice one by one every reaction with this. So as I have explained to you, you should know which is electrophile and what is Lewis acid and where it will go. So this reaction, since chlorine is reacting, it is called chlorination. Here nitric acid is reacting, so nitration. Nitration always is done with conc H2SO4. H2SO4 is having dual nature. One is like Lewis acid, the other is like as nitrating mixture, and sulfuric acid is combining, so sulfonation, and one molecule of sulfuric acid will be as addendum, another molecule of sulfuric acid like Lewis acid. Then this is alkylation, reaction with alkyl halide is alkylation. You have done these all named reaction in mechanism portion long back. And this is your acylation, reaction with acid derivative. So this is acylation. Reaction with acid anhydride, that is again acylation. Reaction with acid amide, that is also acylation. So difference between acylation and acetylation, this is all I explained in mechanism chapter. So you can revise from there. So these five steps of the reaction, which are substitution reaction and our SE2 reaction, that is your bimolecular electrophilic substitution reaction. So why electrophilic? Because electrophile is substituting hydrogen, and that's why. And in the rate determining step, this is the rate determining step. Two of the reactants are combining, two molecules are undergoing change in concentration. So it is your bimolecular reaction. So this is about your substitution reaction. Next we will do electrophilic substitution reaction. Last two reactions which you have seen, alkylation and acylation, that is also called Friedel-Crafts alkylation and acylation. It is different from nucleophilic reaction, nucleophilic reaction mechanism you have done in mechanism part, there you can see. Next property is oxidation, shown by this. So this is simple reaction you have to learn with condition. This is malic acid, you have done in geometrical isomerism this acid, and further water is out, one molecule of water is out from here, and so maleic anhydride is formed. On burning, it forms carbon dioxide and water vapor. Important is it burns with a smoky flame, sooty flame, and when heated very strongly at high temperature, then it forms a biphenyl. Two molecules of benzene will be linked together and will be forming biphenyl. So these are the reactions you have to learn. Another thing that you have to do about the substitution reaction is meta-directing and ortho-para-directing. So if you have benzene ring and already there is one chloro group, and again it is combining with another molecule of chlorine, then where this chlorine should go? That is, it should come to this position, or it should come to this position, or it should come to this position. If you have a HONO2 group, then this part will go where? Here or here or here. So this position of incoming group will be decided by already which group is present in the benzene, not by the nature of the group which is coming in, but which group is already in the benzene ring. That will be deciding that next coming group should go to what position. So you have studied earlier that this position is called ortho position with respect to this. This position is called meta position with respect to this. This is called para position with respect to this. So whenever a group is coming, is being directed by a group present here to the ortho position, then ortho as well as para, two products will be formed. So you have to learn that. So some groups are ortho para directing, means that the incoming group like chloro is there, and it is combining with another molecule of chlorine. So you will have two products. One will be chloro at ortho, and also you will have at para. Ortho and para dichlorobenzene nomenclature part you have done. So a group is this chloro group is ortho para directing, and if you have one NO2 group is here, then this chloro group will not come at ortho and para position. Instead it will go to the meta position. Only one will be formed, meta. Okay, so the group which is attached here, that group will be either ortho para directing or it will be meta directing. Ortho para directing groups are chloro group which have lone pairs and attached with a single bond. OH group having lone pair, NH2 group having lone pair. So this is the point of identification. If these groups with a lone pair and a single bond attached to the ring, then incoming group will be going at ortho at para position. But a group which is attached, NO2, if you write the structure, it is having this structure. So this group which is attached, if it has a double bond, the next incoming group will go at meta. So examples are CHO group, which you write like this also. So our double bond, ketonic group, carboxylic group, and so these groups are in nitro group already we have done. These groups are meta directing. So uses you will do from the book, and rest of the part of the things that you have done in the mechanism chapter. So you will cover up from there. So here ends your organic portion completely.